Hi. So we're continuing to work on finding the zeros for our quadratic equations, and we've learned that when we can't see any x-intercepts, that often indicates that there are some imaginary roots or imaginary zeros. So we're expecting 2 imaginary zeros for our quadratic equation, which has a degree 2. This one is not written in graphing form, it's written in standard form. And so if we could factor it, we would, but this doesn't factor. We could complete the square to get it into graphing form, but we can also use the quadratic formula. So let's go ahead and do that to see what these imaginary zeros look like when we're solving using the quadratic equation. So our first step is going to be to go ahead and identify what our values of a, b, and c are. And a is the coefficient in front of our x squared. B is the coefficient in front of our x term, and c is our constant that doesn't have any variables in it at all, which is why we call it a constant. So a is 1, b is -4, and c is +5. So let's go ahead and plug this into our equation. We know that x equals the opposite of b, so the opposite of -4 is +4. Plus or minus the square root, we need b squared, so -4 squared, and I'm going to put that in parentheses just to remind me that if I'm squaring a negative in the calculator, we need to use parentheses as well. It just helps us be careful. B squared minus 4, a is 1 and c is 5, and all of that goes over 2 times a, or 2 times 1. So let's continue to simplify and see what we get. We get 4 plus or minus, -4 squared is 16, minus 4 times 5 is 20, and all of that is over 2. So 4 plus or minus the square root, 16 minus 20 is -4, and all of this is over 2. So as we're working, we can see here we have a square root that's a negative. So this is where that imaginary numbers come into play, and we need to use I to be able to simplify that. So when we go ahead and simplify, we have 4 plus or minus, that becomes 2i, right? Because we split that -4 up into -1 and +4. And all of that is over 2. And so we want to do a little bit more here, because notice the 4 plus 2i is over 2, and both of the terms in the numerator can be divided by 2. So we can go ahead and simplify this further. In fact, sometimes it's easier to just go ahead and split that up. 4 over 2 plus or minus 2i over 2. It helps us see that we can simplify each term. And then actually notice we actually have this by splitting it up in that a plus bi form. So one more step here. 4 divided by 2 is 2 plus or minus I. And that's going to be our final answer. So there's 2 imaginary roots, 2 plus I and 2 minus I. They're imaginary roots, and they're written as complex numbers, that a plus bi form.